Hello everyone, my name is Chen Zhi. Today I would like to present this paper. The research team consists of several collaborators from different institutions in Chongqing, China. They all are members of IEEE. So the research background, first, MI classification based on EEG signal is a typical BCI paradigm used to communicate with external devices by extracting features from event-related desynchronization and synchronization. We can perform classification of the MI task. Besides, in recent years, CNN have been increasingly applied to EEG classification tasks. However, most CNN-based methods adopt a single convolution mode with a fixed kernel size. In response to the above problem, they proposed MSHCNN. As shown in figures, it consists of 4 parts. First part is data input blocks responsible for data preprocessing. Second part is M1D-CNN and M2D-CNN feature extraction block. Different color shades represent different sizes of convolution kernels. Later will be called CK. 1D used for extractive temporal feature, 2D used for extract spatial temporal feature. By the third part, feature splicing block concatenates the feature extractions by 1 dimension and 2 dimension. That's the models can learn both temporal features and spatial features at the same time. Final part, feature classification, pass through average flow blocks and use softmax in output blocks to classify motor imagery. Why they claim to use different CK is that from the figures 2a, we can see that different subjects have different peak accuracies on different kernel sizes. From the figures 2b shows that temporal feature and spatial temporal feature perform differently. Therefore, they choosing the top 3 accuracies of each dimension size of the CK to be their model's hyperparameter. Right blocks plot shows that compared to baseline EEG-net and DeepNet, their models achieve best average classification accuracy. In the ablation experiment, also has increased accuracy to prove the effectiveness of hybrid CK size. Left table shows that their models have the most numbers of subjects of highest accuracy, and it also has highest average accuracy. The steps of feature enhancement methods they proposed: first, determine the spatial symmetric channels, for example C3 and C4. Second, use formula 5 and 6 to obtain the difference CD and similarity CS. Third, concat the CD and CS to the original data in time dimension. They use EEG-net and their models to evaluate their features enhancement methods. This result shows that the classification accuracies of the 3 encoding method has been improved compared to EEG-net. Also, the SA underlies encoding method they proposed has highest accuracy. Last graph, it is the intelligent artificial sleep control system. The accuracies of the validation set and online experimental results are shown in the right table. It can be concluded that the methods they proposed obtained higher average accuracies than the EEG-net model. To make a conclusion, they propose MSHCNN, propose a more robust encoding method, and apply to online artificial limbs control system. This is my presentation. Thanks for listening.